Alright, so the first principles allows us to determine a function that describes how another function is changing at any point or for any value of x. As you can see on the board over here, we can estimate it by picking 2 points, and we can reduce our amount of error by reducing the distance between the 2 points effectively to 0. However, the issue arises is that when we reduce it to 0 using our conventional math, it doesn't work anymore because we get something over nothing. Using limits that we learned last lesson, we're going to make it such that we can evaluate what this is going to be. So consider f of x is just any function that we're interested in. F dash of x or f prime of x is going to be the function that describes how f of x is changing for any value of x. Putting this together, we can define f dash of x as going to be, and we'll set up what we had before. We're going to have f x plus h, where h is the difference between this point and this point here. So h is the additive part there. Can we all see that? Then what we're going to do is we're going to take the original f of x away. So this is y1, this is y2. So then downstairs what we're going to have is everything divided by h. So we're taking the average of 2 points, and it's all sort of the average. Now to get around the shortcoming of everything turning into 0, what we're going to do is we're going to observe h as it approaches 0. Does this make sense? Nope.
What's the rate of change?
The rate of change, the slope. Good question though. Is there anything else, guys? Don't be shy, because if we push ahead and there are things that you're like, what's he talking about? Or he hasn't explained this clear enough.
What did you say h was?
H is the distance between this orange line and this orange line.
And how can we see that? Oh, yeah, okay.
Yeah, do you see it?
Yeah.
Yeah. So if we go across to, not that one. Okay, what's that one? If we go across to this one, see how that when h is 0, they're on top of each other. When I split them apart or increase h, they move apart.
Yeah.
Does that make sense?
Yeah.
So what we're doing is we're using that formula on the board for now. We'll just treat it like a formula to make h nothing, which will allow us to estimate the slope with just a singular point. Is that cool?
Yeah.
Okay, so let's jump into an example and show you how this is actually applied. Given g of x equals x squared plus 3, find g dash of x. What's g dash of x again? What does it describe?
The rate of change
The rate of change of
for x values.
g of x. Yeah, excellent. Okay, so let's apply this. G dash of x is going to equal, we apply a limit where h is approaching 0, or basically becoming 0. We prepare our first principles formula, x plus h, take f of x, and we're dividing it all by h. Next step, sub in the values. Every time you see x, change it to, in brackets, x plus h. Up here, it's going to be, first one's x, so it becomes x plus h, plus 3. Take x squared plus 3, all over h. Seem cool so far? Yep.
Do you always make put h into 0?
In its, do I always put it in like
Like-
parentheses?
Down.
Yeah.
Limit.
Yeah. Yeah, h is always, yeah, it's always 0. Because we're observing as h becomes nothing. Okay, working this out, I can't apply the limit yet because if I do, what will end up in our denominator? 0. We don't like that, do we? Not as mathematicians, no. Okay, so firstly we've got to get rid of the h in the denominator. To do this I expand outward, so I use my fast expansion here. X squared plus 2xh plus h squared plus 3. That's the first bracket. The second bracket is take x cubed, take 3. There's a negative one on that one and that guy. And it's still all over h. Now next step is something really cool. If you've done this right, it works out quite easy. See how you've got an x squared here and a take, is that a cube? No, that should be a squared. Sorry. See how we've got an x squared there and then we've got the polar opposite one here? Wave goodbye to them. Bye x squareds. And then do you see the 3's?
Yeah, you can disappear.
Now, everything that remains upstairs has an h on it, doesn't it? So because of that, they go away as well. So this simplifies down to 2x plus h. Now, let's apply the limit. What do we get left over? As h approaches 0, we get a 2x, which is unaffected by the limit, and then this guy basically becomes 0. Hence, how cool is that? So that function, g dash of x, which is 2x, describes the slope of g of x for all values of x. So we can predict the slope of the tangent for any value along that curve, which would be this guy here. Oh no, not that one. Not that one. Oh, they're both the same. Anyway, do this one. Yeah, seem cool? Alright, you guys want to do one? Yeah. Alright, you guys will do, given, what's your favorite letter? Don't even think about it, Zoe. Letter.
Oh. So I'm not awake.
H. Nice. Capital H of x equals, and we will go x. Be really mean, I'll give you a cubed.
Thanks. No, thanks.
Find h prime of x or h dash of x. Or in other words, find the function that describes the slope of h of x for any given value of x.
So on the first one and the other one, in the actual equation, do you still keep it f of x?
Yeah, on the right hand side it stays as f of x.
You don't put it as g of x.
Oh, sorry, that was a mistake. No, it should be whatever that is up there. I've just been doing g of x so often. Alright, thank you.
Variables again.
boys, you focus.
Yeah, I'm running copy it.
Don't just copy, do.
I'm copying the one that we've done already. That way it's in my book.
You go to the gym to copy or watch other people? Or do you go to the gym to pump iron? Like Schwarzenegger.
No, I go to watch Dylan.
Just go watch me. Watch Fun Behind Me. That's good.
And that is why you'll never be as big as Dylan.
Yeah.
Dylan's not very good.
I don't know.
No. I could let you through it.
I hope Twix is better than
Can you come back to that one?
I hope you become overcome with grief, not how many bloody legs.
That's the wolf side to pillars, but I hope both sides will go off, actually.
Boys, you're distracted again. Do we understand the process, guys?
Just make Devon equal to 0.
H.
Yeah, anyone H equal to 0.
Yeah. And that's the
So they'll just work out to be x and 3x squared.
So what's our final? How do we describe our function that describes the slope of the other function? What is it? Leishman? What will the final expression be?
final expression.
Hmm.
3x squared plus 3x.
No, just the
Just 3x.
Just h equals 0.
Just 3x
Oh, yeah.
squared. As you're going to,
Oh,
You'll understand after.
Do you
Get
understand?
down there.
What are you saying?
You didn't get it.
What are you saying?
so for now guys, a lot of this topic is going to seem like a bit of witchcraft because we can't spend 100 hours trying to basically figure it out all ourselves. But this was effectively the stuff that Newton came up with back in the 1600s. It took him quite a number of months. And even his math didn't make sense, but he knew how to get the final answer. He just couldn't describe everything along the way. He was stuck on the idea of limits. He had the gist of it, but he just didn't know how to describe it. Now, the final thing, we're not going to do any working out for it. I'm just going to tell you two things. One, rather than calling this the function that describes the slope of any other given function for all values of x, we're just going to call it the derivative. Is that cool? So this is the derivative of that. Then the next one, what happens if it's not a function? What if it's in relationship form or relation form? Y equals x cubed. Well, we can use Leibniz notation and we say d over dx y is going to be, and in this case it's 3x squared. What this means is d stands for the change in y with respect to the change in x, or the change in y over the change in x is 3x squared. Just different notation. Changing it up slightly. We'll leave it like that.
You just have to.
What's up?
Don't worry, figure it out.
And that's a wrap.
Change.
So the one on the left, that's the German notation. The one on the right, that's the British notation. You can use either.
German.
Hmm.
It's a bit German.